Now, this is what the complete discussion about how you can draw the grid lines. Now, the next exercise where we are going to validate the software, whether your software is giving the right result or not. But along with that, we have to learn a lot of things that what are the different axis system, what is the concept of releases, how to assign the loads, what are different types of the loads, uniformly distributed, uniformly varying load, point load, everything you can understand how to do these all things, how to know all these things in the ETABS software, and how to see the tension force in member, compression force is a member, how to apply the uniformly distributed load, and how to see the reaction, everything that we will see in this exercise. So the first part we have completed, that is about grids. Now the second part is what? Validation of this ETABS software, whether your software is giving the right result or not. So we are going to take a simple examples. That is what we will model this truss. We will assign all these loads, and this is what the manual result. This is the manual result. I will have to see whether your ETABS software is giving the correct result or not. Whatever the result is given by the software ETABS and whatever the result we are getting by the manual calculation, whether both of them are matching or not. So this is called as validation of your ETABS software. You might have learned the assumption of analyzing of truss. What are some assumptions for the analyzing of the truss? Let me sum up all these assumptions. So these are some assumptions made in the analysis of the truss. So weight of the member can be neglected. When you are going to analyze the truss, so member of the element will be what? Neglected. All the members have the uniform cross section. That might be known to you. The truss is made up of the summation of different individual elements. So these individual elements is going to form the complete truss. So these each individual elements will have the uniform cross section from this start point to the end point. This cross section will be what? Same. Here, if suppose the depth is what? 200 mm. So at this end, the depth will be 200 mm. First, all members have the uniform cross section. All external forces are applied only at the joints. All the loads are considered only at the joints, at the intersecting point of two frames, two elements, this element and this element. Next, all members have only axial forces, means all the members are subjected to axial forces that may be either tension, that may be either compression. These things will be there, either tensile or compressive. And last and most important is members are connected at the joint through the pinned connection. So this connection is what? Pinned. This connection is what? Hinged. Meaning of this pin or hinged means what? This joint is not transferring the moment. This joint is not carrying any moment. It is transferring only the axial stresses to the elements only. So all the member of the truss will be subjected to axial forces, line forces, that may be tensile or compressive. Okay, so these all are some assumption, but these all are not much important in comparison of this last one. Members are connected at the joint through the pinned connection is the most important. That is what the main concern to discuss, this assumption for the analysis of the truss. So this you need to keep in mind. That is what needed when we will practice to model this truss in the ETABS software. Okay, first thing. Second, what are the different axis system? Can anyone explain? So basically there are three different axis system. One is your natural axis system. Second one is your local axis system. And third one is your global axis system. So what does mean by this natural, global and local axis system? First try to understand and just look at this. This is the global axis system. The axis system which is representing entire model called as what? Global axis system. But if you are going to look this model completely, so it is having the three dimension. This is X direction, this is Y direction, and along the height, along the length, along the width, along the height. So this complete model is having what? Three dimension. So it is the 3D model. So we are going to define this 3D model with this axis system. So it is called as global axis system. So this is the first thing. Second, if we are go inside of this model, so this model is consisting of different elements. Column is one element. These beams are one element. These horizontals are lateral elements is actually your beam. and here over this beam there is the presence of slab. So this model is consisting of different elements. Each individual element is also 3D element. Each individual is also solid element. It is having width, it is having length, it is having its width, and it is having its height. You are first time representing your entire model. So if you are going to representing your entire model, whatever the things along X direction, so I am considering this column, okay, this is along X direction. Both of the columns along X direction. These both of the columns along Y direction. All the elements over the height along the Z direction. So this is a representation of your entire model. But when you come inside of this model, so these columns are there, these different columns are there. So these different columns are what? Different individual columns having its axis system, own axis system. Okay, so this is what solid element. It is having its length, it is having its width, it is having its depth or height. So I need to have one more axis system to represent each individual element. So it is going to become what? Here, along width, we are going to represent is 2, 2. Along length, we are going to represent is 3, 3. Along the height, along the depth, we are going to represent is that by 1, 1. So this is called as what? Local axis system. So when you are representing your entire model, it is what called as global axis system. We are going to represent your individual element by the axis system. So called as what? Local axis system. But when you come inside of this each individual element, so it is made up of solid particles. This one particular beam is made up of individual tiny particles. These all tiny particles is also having the 3 dimension. And I need to represent by one direction, by another direction, depth about another direction. So it is also the 3D element or solid element. So this axis system is called as what? Natural axis system. So very first is your global axis system. Second one is your local axis system, whereby representing this column by one axis system, beam by one axis system, slab by one axis system. Okay, every element will have its own axis system. That own axis system of each individual elements called as local axis system, and the axis system which is representing your entire model called as global axis system. And each element is made up of small particles, solid particles, which is having its own 3 dimension, and it is going to be represented by the axis called as natural axis system. So this natural is not much important, and we are not looking at in ETABS software. Actually, main concern with global axis and with your local axis. Come to your ETABS, see. It is what? Local or global? It is global axis system. It is representing your entire model. Now, I would like to see the local. So how to see that? That is the other part of discussion. I will cover in detail. But right now, I would like to see, I would like to show you local axis for the frame. Say apply. See, it is what? These are the what? Local or global?
Local.
So here column is not present. So otherwise you can see the column also axis. If you are having the slab, so slab local axis system will also be there. So everything you can see, like local axis you can see, and global axis also you can see. Okay, is that all clear to all of you, the concept of global, local and natural? Now we have to model this truss. So can you tell me, okay, this is the elevation view, plan view or 3D view? What kind of this view is? Elevational view. Okay. So can you tell me how many grids are there in X direction? How many grids in Y direction? So, okay, let me explain first case. Here, I am going to look at this model from the top. So from the top, this is the X direction. I'm actually what? 3 planes are there. 2 planes will be there. This is along the Z direction. ETABS considering what? Along the horizontal direction as X axis, along this direction as Y, and height, over the height, it is considering Z. So over height it is Z, here I am going to consider X, it is I am going to consider Y. In plan direction as X and Y, over height as Z. So this truss may be in XZ plane, or it may be in YZ plane. So in which plane you would like to consider your model? XZ plane. So it is what? XZ plane. This is from here. This is from here. Now from here. Now from here. Got it? In this way, this drawing. So like along X direction, this is the first, second, third, and fourth. How many grids are there along X direction? 4 grids are there. And spacing of between this each grid is what? 4 meter, 4 meter. Uniform spacing is there, 4 meter, 4 meter, 4 meter. Got it? And this is over the height or not? This is over the height. So how many levels are there? 2 levels are there. These 2 levels will be there. That is what? Over the height. And, okay. So don't consider these points as counting it to be number of grids. Along the X direction, how many grids are? Tell me fast. 4 grids. 1, 2, 3, and 4. And these are the over height definition. So this is what? One level. This is the another level. 2 levels are there. Now clear this all. We have to proceed to model it in ETABS software. Go back to your ETABS. Go to file. Go to new model. Unit system will be what? Metric SI. Say okay. Now, how many grids in X direction? 4. How many grids in Y direction? 0. But 0 is not there actually. Hello? No. You are correct. You are thinking right. But actually this line, okay. If another truss, I am taking what here? Another truss I am taking here. So what you will count it? Either you will count it as 1 or not. You are counting it to 2. You are counting it to 3. Now tell me, how many along Y?
1.
Very good, very good. So let it to be 1. Now spacing of grids in X direction, how much? 4 meter. Spacing of grids in Y direction, so it is 1 meter. Actually, it is not accepting 0 value. So put it as 1. Okay. Now this is done. I need to go to custom. No. Let it to be as it is. Now over height definition. How many levels are there? Actually 3 levels are there, not 2. ETABS software will consider this level as base level. Automatically ETABS software will give the one level as base. Next to that, then next to that. Okay. So we are going to neglect this level. ETABS software by default will give this base level. Next to this is the first. Next to this is the second. I need to have this height. Then I need to have this height. How I come to know this height?
Tan 30.
Very good. Height. This is the height I would like to know. Height upon your base is equal to 10. Angle is what? 30 degree. So I need to have the height that will equal to your base into tan 30. Okay. Base is how much? Half of this 4 meter is going to become 2 into tan 30. Let me know what is the height for first level. 1.1547. Very good. Now next height I need to know. This is the height first. Let it to make it as height first. Next height, total height will be. Actually first we need to calculate the total height. Total height how much?
3.46.
Okay. How to calculate it? Same. Height upon base equal to tan 30. Base is will become 4 plus this half 2 will become 6. So second height will equal to 6 times tan 30. How much it is? 3.4641. Now, this is the first height. Difference of height is what? 2.3094. So this is what difference in the height. Close it. So first height is 1.1547. Second height is 2.3094. If you are going to add these two value, you will get 3.4641. Go back to your ETABS. Now over height, how many levels you would like to have? 2. In addition to your base. Typical story height, make it as 1 meter. I will let you know what to do. Bottom story height, make it as 1 meter. Let it to be. Go to custom and go to edit story data. Now here we will correct it. So to base level is actually your 00. First level will be what? 1.1547. Okay. Next level 2.3094. Say enter. Now total height is going to become 3.4641. This is the cumulative height. Elevation means cumulative height. Base to first 1.1547. So the total height is what? 1.1547. 1.1547 plus 2.3094, you are getting 3.4641. So elevation showing you cumulative height. So that is the case. Right now, let's say simply okay. This is all done. Let's say simply okay. Now I need to have these grids. Check this grid option. Let's say okay. Once you done this, this is your plan view. I need to work on elevation view because as you said, our drawing is the elevation view. So modeling we have to do in elevation. So actually it is not possible to model in plan. It is what the drawing we have to draw over the elevation. So go to elevation along the grid first. How? I will explain all these things, okay, later. But for the instant, go to elevation and along the grid first, let's say apply. Now it is your elevation view. It is now, and only in elevation view, you will be able to see the label of the levels. So in plan view, you will not able to see. Obviously, this is the plan. How you will be able to see the labels of the level? Only in elevation view, you will be able to see. So along the grid first, I would like to see the elevation apply. Okay, I have to do the modeling of the truss here right now. Now, just go to first, go to take frame. I will explain these things all also, but close it, all these things. Okay, this is the first point. When you are taking your cursor to the particular point, so this kind of sign you will get, red sign. Then only you have to click over that. Unless and until you are not getting this reference point, you don't need to click over that. Otherwise, there will be the chances of error. So I'm taking my cursor here. Okay, so that's good. Then I can click over that. This is the first way. Second, like suppose I have to start from this point, okay, and I have to stop my point here, somewhere here, because my element is going to end here. Check it, your drawing. Your element D to E is going to end here. But do you have any reference point to end this line? We need to find some solution for that. Okay, we will do that. Forget that. Come to this. Okay, if I'm taking the line continuous to this point, so I need to have this some midpoint here in between of your BC. Look at this. In between of your BC, I need to have this midpoint. That also I'm not able to get here. So whenever you are going to start the modeling in ETABS software, one thing you need to do, right click on your mouse on the screen, go to snap option, and here over this dialog box you have to work. Some option you have to check. I will explain all these option in detail on later stage. But right now, we have to check this line ends and midpoints. Check this option and let's say apply line ends and midpoints. Midpoint is most important. Let's say okay. Once you click over this okay, go to this frame, close it. Now from this point, I will have to take the line to this point. Now I'm getting the midpoint or not? Yes. Now I'm going to click here. But observe the thing at this void point, at this base point. Observe the thing. Okay. What will happen here? What happened here? Support has been assigned by the software. Okay. So every time when you are going to work with ETABS software and whatever you are going to do at the base level, software will by default assign the support to that joint or that point. Why? It is because your software considering this base level as the foundation level. Okay, I have not assigned any support to this point, but still the software is what assigning because it is the base level. If I'm trying to model from here, see, from here to here, no support assignment will be there because it is the story level. Whenever you are going to take only the line from here to here, software will assign the support.
Yes.
Okay, now close it. This is the first point. Freely move to this point. Click over this. Okay, I want to come back to this origin point. Click over this. Now come to this point. Okay, see, I will have to take the help of it is what the frame drawing, modeling of the frame, modeling of the beam element, modeling of the line element. So how to draw the line element for all the beginners? Very simple. You have to click on the first point. You have to click on the first point from where you want to start the drawing of frame. Click on this first point. Freely move to the next point where you want to end your line. Just click over that. Now, it is now continuous. Your command is now continuous. I would like to take the help of this continuity. I will take the advantage of this continuity. You want to start the next point from here. If you want to stop the line here, then what? You have to right click on your mouse. When you right click on your mouse, the continuity will be stopped, but your command is active. If I'm going to click here or escape button of your keyboard, so this command is completely off. I'm going to press click here, select object. Now command is completely off. I'm not able to draw the line. But if I'm taking the frame, Now close it. I am taking the line from here to here. Now I have to take again the line from this point to this point. I will take the help of this continuity and active of this command. Click over that. Now I don't want to draw the line here. I would like to draw the line from here to here only. Okay, so I need to stop the continuity. So right click, continuity will be stopped. Now click on this first point, but the command is active. Click on this first, really move to this. This is done. Now select this, make it to be deleted. Now select this too, make it to be deleted. Okay, now again go to frame, close it. Now from here I would have to start my element. Click on this first point, come to this. Now click here. Okay, now I will take the help of this advantage of this continuity. Then click here. At every point you have to break the element. Okay, if you have any confusion and doubt, you can see your drawing. Each elements are individual. All the elements are connected at the particular point. Okay, come back to your ETABS. Okay, I'm taking the help of this continuity. Click over this. Now the modeling of this frame has been done. Come to this. Now the modeling is going to be done. Okay, now all this has been done. Okay, next what I would like to do, another point is at this. So take the frame, close it from this point to this point. Click over that, right click on your mouse to stop the continuity. Then you have to click on this first point, then move to this point, click over that, right click to off the continuity. Now from here to here, this is done, right click. Now from here to here, this is done, right click. It's all done. So in this way,
Yes.
you have to do the modeling of the truss. After the modeling of this, what we want to do, we want to remove this joint. You want joint assignment. Here what? The hinge support has been assigned. Go to 3D view. Go to this 3D view. So it is called as what? Hinge support. ETABS software will assign the hinge support to all the base point. It is called as what? Hinge. It is looking at like a tripod. So how many types of the support? You know, hinge support is there, fixed support is there, roller support is there. So go to elevation. Along the grid first, say apply, close it. So here, what support is there? Can you tell me? At the B, at the C, is there any support? No. Okay. So I want to select the joint. Support assignment will be to your joint, not to the frame and all. Okay. Understand the concept of selection and deselection. Before of that, very important, note it down. Those who are the beginners with this ETABS software, whenever you are going to work with this ETABS software, your concentration should always be on bottom left hand side and right bottom. Okay, why it is? Whether you are working with one story, all stories, similar story, with which option you are working, that is very, very important to know. What is the importance of this one story, all stories, similar story? What is the role? When to use one, when to use all, when to use similar. But your concentration should always be on right hand side bottom with which option you are working to avoid the errors and mistakes. So if I'm going to drag it from left, I'm going to select here. So how many selection is there? One joint selected. Okay. Another thing, suppose here again I'm trying to select the joint. But see what happened here?
One frame is selected.
One frame is selected. Beam or this line is considered as a frame element. I will come to that point. Types of elements in the ETABS software. So two types of elements are there in ETABS software: frame element and shell element. Frame element means your beam, column, spindle. These all considered as a frame element, and slab, shear wall were considered as a shell element. Okay, drag it from left to right. Okay, how to make the selection? You can directly click over that element. You can click over that joint. If slab is there, you can click over that particular slab. So the selection will be there. This is the one way. Another way, so you need to drag it, click on this first point, drag it left to right. So whatever the element which is completely coming in this box, that will be selected only. So what if I'm dragging from left to right, what thing is going to be completely come inside of this box? Joint is also one element. So dragging from left to right, what things completely coming inside of this box? Joint is there. So that joint is now selected one joint. but this all frame is not going to be selected. Okay, I am dragging from left to right. What things are coming inside of this box completely? Two joints, very good. And one member, one frame, very good. Left it. See, two joints, one frame. Right or wrong?
Yes, sir.
Okay. Drag it from left to right. See, consider
Okay,
it as
okay.
one frame. Now tell me.
3 joints, 2 frame.
Very good. Three joints and two frame. Now see, left it. So three joints, two frame, it is now selected. So this is the way. But if you are doing the same thing from right to left, what will happen if you are dragging from right to left? The things that is going to be cut by this box, that will be selected, plus the things which is completely coming inside of this box. Okay, joint is 2 and this frame is going to be cut. This frame is going to be cut. This frame is going to be cut. 5 frame, 2 joints. Understood? Okay, this is what the concept of selection and deselection is. Very basic and simple thing, but I am sharing this for the beginners. Those who are knowing, that's good, very good. But for the beginners, those who are going to look at this ETABS software, so they are having the fear of doing all these things. So I'm trying to make it simple for all of them. Now next, actually our intention is to remove this support condition. Actually in our model there is no any support to this point. Support only at left and right. Here it is the hinge, here it is what? Roller. So what I would like to do, drag from left to right. So the joint is now selected, one joint. Drag it from left to right, another joint. So both of the joint is now selected. Go to assign, go to joint, go to restrain, because I told you support will be assigned to the joints. So go to joints, go to restrain, and here fixed support, hinge support, roller support, and it is what? None. And these all are the restraints. I consider that you all are well aware with the restraints. What does mean by restraint? The restriction to your motion. That is the mechanics topic. So it is what? Restraints. Translational restraint and rotational restraint. So I'm not going in deep of explaining these all things. It's very basic. But if you are not well aware with it, so just search it and understand it. But if you are not willing to look at this, so directly focus to these images, these icons. So it is the fixed. Accordingly, restraint will be selected. If hinge, restraint will be selected. If roller, restraint will be considered. And it is what? None. Now, here is there any support? No. So select this none. Let's say apply. So none is there. Nothing is there. Okay. Left hand side, hinge support is there. So I no need to worry about it. In our example, on the left hand side, hinge support is there. And on the right hand side, there's a roller. So select it, drag it from left to right and make it as what? Roller. This roller, let's say apply. Now next. This is all done. First, we are trying to complete our model. So some part of the modeling we have completed. Now next, this is the complete frame. But in our actual model, it is like that. In our model, this is the complete line. In our drawing, it is what? Break. Two different elements are there, right? Okay, I have to break this frame about this joint. How to do that? That is the part of editing. I will cover this also in detail in the upcoming session. But for an instant, we are trying to understand it, how to execute. Select this frame, drag it from left to right, this joint, one frame, one joint, go to edit frame, go to divide frame. The first option, in how many numbers you want to divide this particular frame. In the second option, break at intersection with a selected frame and joint about which point. ये चीजें आपने डिफाइन कर दी तो ये ब्रेक हो जाएगा. हमने डिफाइन कर दी है, फ्रेम भी सिलेक्ट करके हमने बता दिया है, ज्वाइन को भी हमने सिलेक्ट करके बता दिया है. सो सेकंड ऑप्शन, ब्रेक एट इंटरसेक्शन विथ सिलेक्टेड फ्रेम एंड ज्वाइन. Okay, now let's say simply apply. Now it is the separate one. It is the separate one, two frame. Same thing we have to do for this side. अभी देखिए हम लोगों ने फ्रेम भी सिलेक्शन नहीं बताया है, ज्वाइंट भी नहीं बताया है. मैं ट्राई करता हूं, अप्लाई, नथिंग विल हैपन. मैं फ्रेम सिलेक्ट करता हूं, अप्लाई करता हूं, कुछ भी नहीं होगा क्योंकि हम लोगों ने ज्वाइंट ही नहीं सजेस्ट किया. सो ड्रैग इट फ्रॉम लेफ्ट टू राइट, ज्वाइंट भी बताइए, फ्रेम भी बताइए, देन ये ऑप्शन एप्लीकेबल होगा. लेट्स से अप्लाई. This is done. Now close it. Okay. So in this way, we have to complete the modeling.
Yes, sir.
Now, save this model in this CAD file as 2. Save this model as 2. I'm going to stop the discussion here. The later part we will discuss in the next session. So in the last session, we have started the modeling of this truss in the ETABS software, and some part of the modeling we have completed in the last session. So this is our model. How to do the modeling of this truss we have seen in detail in last session. Some part I missed to cover before of the starting of the modeling. So when you are going to create the model in your structure, so in ETABS software there are two types of elements. One is your frame element and another will be your shell element. What does mean by this frame element? What will be included in this frame element? Your beam, your column, your spindle, your links, these all will consider in frame element. And shell element include your floor slab, shear walls. These all are included in your shell element. So frame element is actually we are considering as line element, whose longitudinal dimension is very, very large. When beam is there, so beam is having suppose a 5 meter length, so depth is what 450, width is what 230. So width is 230 only, depth is only 450. Try to understand. Our length is what 5000 mm. So length is very, very large in comparison of these two dimension. That's why we are going to call it as line element. So for all the line elements, software is considering as what? Frame element. So line elements are what? Your beam, your column. For the case of column, height of the column is very large, but cross-sectional size of your column or lateral dimension of your column, transverse dimension of your column is very less, 230 by maybe 600, or suppose height of the column is 3 meter, means 3000 mm. So length or height or depth of the column is very large in comparison of its cross-sectional dimension. Okay, that's why we are going to call it as frame element. And shell means your area element, means in plan two dimensions. That is suppose this x direction, this is suppose y direction. So along x direction, the size of the slab is suppose 7 meter. Along y direction is suppose 5 meter. So 7 meter by 5 meter. And depth is what? Suppose 120 mm. Thickness of the slab is what? 150 mm. So 7000, one dimension is there. Another dimension is what? 5000. In comparison of its in-plan two dimensions, the depth is very, very less. Depth is only 120 mm. Try to understand. 7000, 5000 and directly 120. So your depth is very, very small. That's why we are going to consider as an area element. So that's considered as a shell element in ETABS software. So whenever you are going to work in the ETABS software, especially for the RCDC structure, like two elements will be there. One your frame element, another one your shell element. Frame elements means line element and shell element is actually your area element. After this, modeling has been done. So these all are your frame element. That's why it is showing what? Frame. Now we have to assign the load over your truss joints. Okay, we have seen in the last session as the assumption loadings will be only at the intersection point of two elements at the joint of the truss. Okay, the loading will be at that point only. At the ends of the elements or at the connecting points of the element, the loading will be only. Here just to show, actually the arrow is showing here. Actually it is this loading is at exactly at the connecting point, intersecting point. So it is 3 kilonewton, it is 3 kilonewton, it is 2 kilonewton. So you know that what are the different types of the loading. So loading will be of three types. Basic three types are there. Point load may be there, line load may be there, and area load may be there. Point load will be your kilonewton, that might be known to you. Line load, kilonewton per running meter over the length of the beam, over the length of the element. And area loading is what? Kilonewton per meter square if it is needed to assign the load over the slab. So that will be what? Area loading, kilonewton per meter square if you need to assign the load over the beam, over the line element, over the frame element. So that will be uniformly distributed load. If you would like to assign the load to the particular joint, so that will be your point load. Or at any particular point of beam, if you would like to assign the concentric load, that will be your point load. So that will be in kilonewton. So these are the three different types of the basic loading that we have to assign in the structure or in the project or in your model. But here our concern is to assign the type of loading is what? Point loading. and that point loading is what? That is over the joint we had to assign that load. Now close it, come back to your ETABS. Now our model is basically ready. Okay, so here the loading we have to assign as how much intensity of the loading is there? 2 kilonewton. So this is what the assignment. If you want to do the modeling, so that you have to do through the draw option. If you want to define something, if you want to set the list of something, you need to go to define. If you want to view something, what things should be in your view, in front of you, so that will be in view. If you want to do any editing work, delete, adding, dividing, sorting, expanding, that all things editing work you have to do through the edit option. Okay, assignment. If you want to do any assignment, you need to go to assign. If you want to analyze the structure, you need to go to assign. If you want to design the structure, you need to go to design. So many things are there. We will see everything in detail, time by time. Okay, but here, right now we have to assign the load over the join. So go to assign. See, all the three options actually has given in your ETABS software joint load. If you would like to assign the loading to a particular joint as a point load, so the joint load is there. If you want to assign the uniformly distributed load to the beam, okay, so that will be your frame load. If you want to assign the loading to your shell, that means your area. Okay, so you need to go to the shell loads. So all options are in front of you. So here our intention is to assign the load to the joints. So go to this joint, go to force. Once you go to this force, here load pattern name, I will talk about it in detail on later stage. What does mean by load pattern name? Right now, don't focus over that. Don't need to worry about that. You just have to click over this live. Okay, what does mean by this load pattern, and what is the role of this load pattern? Okay, how this will affect on your assignment of the loading. So that all things we will see on later stage. Right now, just remember that when you will practice, make it as what? Live. Thereafter, force in global X, force in global Y, force in global Z. So as I told you in the last session, ETABS software considering the global axis system in this direction as X, in this direction as Y, and in vertical direction as what?
Z.
Very good. Now close it, and coming back to our model. So as you can see, the loading in vertical direction, it is what? The elevation. We have seen that it is not the plan view, it is not the 3D view. Your truss is what? Elevation view. So elevation means it is in Z direction, vertical direction 2 kilonewton. But one thing you have to remember is downward direction. Coming back to your ETABS. So I would like to assign in Z direction. So go to this Z, and I would like to assign the 2 kilonewton. Okay, now say simply apply. Try to understand this panel, how to use it. I will let you know. Very interesting it is. Apply. Nothing will happen. No selected object were found to receive this assignment. It is saying that what? There is no any object is in selection over which this load will be assigned. So that we need to make the selection for that. One joint is selected. Okay. Now I would like to go to this dialog box, and now say simply apply. Now assignment has been done. But the problem is what? It is in upward direction. Our intention is what? Downward direction. So what thing I did wrong? Here I have taken positive 2. So it is wrong. Then what? So here these three options are there. So make sure that replace existing load. So मैं क्या करूँगा? वापस से ये joint को select करूँगा. Replace existing load option here it is selected. तो जो भी यहाँ पर load assign है वो replace हो जाएगा new assignment के साथ. So मैं इसको क्या कर दूंगा? माइनस यहाँ पर पुट कर दूंगा, माइनस, एंड लेट्स से अप्लाई. सो ये अपवर्ड रिप्लेस हो जाएगा, रिमूव हो जाएगा विद माइनस साइन से अप्लाई. नाउ इट इज डाउनवर्ड. ठीक है. व्हेन योर ऑप्शन इज व्हाट? रिप्लेस एक्जिस्टिंग लोड इज चेक्ड. नाउ अनदर ऑप्शन इज देयर. ओके, सपोज बाय मिस्टेक आई हैव असाइन्ड द downward direction of 2 kilonewton load, but my intention to assign 5 kilonewton load in downward direction. So what I will do to keep 5, how much value I have to add to these 2?
3.
Obviously 3. So अभी यहाँ पर मैं क्या करूँगा? 3 वैल्यू लूंगा, रिप्लेस एग्जिस्टिंग दूंगा, तो क्या हो जाएगा? पहले तो ज्वाइंट सिलेक्ट करना है आपको. फर्स्ट यू हैव टू सिलेक्ट योर ज्वाइंट. -3. If replace option is checked, what will happen? This load is going to be removed. This new load will be assigned. So that is your intention. Our intention to make this 2 kilonewton to 5 kilonewton, convert to 5 kilonewton. So it should be what? Add to existing load. So पहले से 2 है, उसमें मैं और माइनस क्यों ले रहे हैं? Just for downward direction. For upward it will be positive. So -2 यहाँ पर already available है, उसमें -3 मैं और ऐड कर दूंगा. So ये आपका बन जाएगा -5 means downward direction. So here the option should be selected as add to existing load. Let's say simply apply. Now it is going to convert it to 5. So that is the case. I just want to share what is the application of these 3 options. And everywhere this option you will be able to see in frame loading, in area loading. So we are trying to understand it here. Now suppose, okay, by mistake I have assigned the load to this joint. Actually there is suppose no load is there. So now I feel that this load should be deleted. So what? I need to select this joint. I will go to this delete existing load, say apply, this is done. So by default software will give you always replace existing load option. Check this option. Now drag it from left to right. The joint is not selected, and now final loading is what? 2 kilonewton. Replace option is always by default will be checked, which is right. Let it to be. Let's say apply -2. Come back to your question. Yeah, on left hand joint it is 3 kilonewton. On right hand joint it is 3 kilonewton. It is actually at the joint. Okay, don't be confused. Okay, drag it from left to right. Drag it from left to right. Okay, both of the joint I have selected in once. Close it. Again I am repeating the procedure. You have to select the joint. One joint is selected. Drag it from left to right. Another joint is selected. Then you need to go to assign. Then you need to go to joint loads. Then you need to go to force. And in this force, what value will be there? -3. Let's say apply to this. Done. For both of the joint in once, I have assigned, okay, as 3 kilonewton downward direction. This is all done. After that, let me check, is there any another load? No, there is no another load. It is what? The reactions, AX and AY, these all are the reaction value. Actually, it is not there, okay? This is not, we don't need to consider this, okay? This is the results after the analysis. You might have done this kind of problem in your academics, in the engineering mechanics. Now, once your modeling gets completed, you have to check your model, whether your model is right or wrong. That we have to check. So go to analyze, go to check model, and this joint check, frame check, shell check, these all checks you have to check carefully. I will discuss it all in detail on later stage. Right now you have to check all of this. Actually, what is this? We are going to check our model. Is there any modeling error? If it is there, then we will try to overcome that error. Okay, let's say simply okay. It takes some time and we'll give the notification. Pop-up will be there. Model has been checked. No warning messages were generated. Means your model is perfect. There is no any error, any warning. So we can proceed for the analysis. So after the assignment of the load and checking of your model, we have to proceed for the analysis. So go to analyze. Analysis means what? See, whatever the load that you have assigned to the structure externally, our intention is to transfer that load to the elements of the structure, elements of your model. So this 2 kilonewton load is going to be transferred to all these members. This 3 kilonewton load will all transfer into all the members, and that we are doing in our academic subject structural analysis. Whatever the load externally has given to your beam, we are finding how much shear force coming to this beam, how much bending moments coming to beam. So due to that particular load, how much stresses is going to be developed inside of your member, inside of your structural element, that we are actually finding out, and that is called as what? Your analysis. So I am going to perform the analysis. So to initiate the analysis, what procedure is there? Go to analyze. You need to click on run analysis. One method. Second, if you are having this quick access bar, what does mean by this quick access bar? I will let you know later. So here also the option is what? Run analysis. So once you click what is the analysis, your analysis will start. Again, there is an option. If you are going to press F5 on your keyboard, so your analysis is going to begin. Okay, so any one of the method you can follow, but if you are beginner with this ETABS software, first time you are using, so go to analyze, then go to run analysis and then click over that. So your analysis will start. So once you click over that, your analysis will start. It takes some time and will give you the analysis result. Here it is showing why warning. I'll talk about it later. Okay, so now here we are having this. See, just click over this start animation. Once you click over this start animation, so you are getting this kind of animation in your structure. It means what? Under the application of the loading, how your structure is going to be deformed, that you can see through this animated shape. But in actuality, the deformation will be not like this. This is showing over what? Large scale. This kind of response will not be there. But yeah, you can understand. And from a long time, we are understanding that your fixed support cannot move anywhere. Your hinge support cannot move anywhere. Your roller support is moving along the translational direction only. So this is the proof. Your hinge support is having the restraint in translational direction, X, Y, and free about rotation. Rotation is free. Here, over the hinge support, rotation is free. And translational movement is what? Restrained. But for the roller support, only vertical translational movement is restrained. It can move in this direction or it can rotate about the axis. So there is no restraint against the translational movement in X direction or about movement. Okay, so that is what the proof. इसी वजह से आपका रोलर देखिए इस डायरेक्शन में मूव हो रहा है. बॉल इज द एग्जांपल ऑफ रोलर सपोर्ट. आप बॉल थ्रो करेंगे, so over the plane it can move in this direction, it can move in this direction, it can move in this direction, but it cannot move in downward direction. Why? Because there is a floor, and floor is what? The restraint in this direction. That restraint is there means what? There is a reaction. Very basic, I try to explain. So this is the proof. Now it is what? Animated shape of your structure under the application of loading, how your structure will deform. Now I have to see how much forces coming in the member of truss. So how I can see that? Go to display. In common approach, I try to explain. Okay. Now in force stress diagram, in this option, go to support reaction. What reactions are there? So go to support reaction. Now under which pattern we have assigned the load, so that all patterns will be available here. We have assigned the load to the structure under the what? Live load pattern, right? Now I would like to see the result in arrow format, say arrow, and I would like to see the upward reaction, Z direction. Let's say apply, close it. How much reaction on this left end? 4 kilonewton. On the right end, it is what? 4 kilonewton. Is it right or wrong?
Right, sir.
Very good. Very good. Now, next, this is the reaction. Now, internal forces in the member of truss. So, go to display, go to force stress diagram, go to frame, pier, spindle, link forces, click over that. Here, under the live load pattern, what does mean by all these things? I will let you know after some time. But here, my intention to see the actual, because member is what actually. So, axial forces, I want to see in the member. So, we will focus to this. Okay. Now, check this axial forces, automatic. It is what? Scale. आपको कितना large देखना है, कितना small देखना है. That is what? Scaling. So, it is not much important. आगे हम लोग इसके ऊपर भी देखेंगे, स्टडी करेंगे. Then, display option. तो आपको इसको भी हम लोग मैं अभी आगे बताता हूँ. What does mean by this? Then, it is what? All these are frame element, area element, pier, spindle, link. What it is? Tell me past. फ्रेम. सो फ्रेम ऑप्शन. अगर मैं पियर चेक करके ये ऑफ करूंगा तो कुछ भी आपको रिजल्ट नहीं मिलेगा, क्योंकि आपका फ्रेम है तो फ्रेम का ही रिजल्ट देखना है आपको. सो फ्रेम, लेट्स से अप्लाई. दिस इज डन. नाउ क्लोज इट. नाउ ट्राई टू अंडरस्टैंड दिस रिजल्ट. वेरी इंटरेस्टिंग इट इज. दिस रेड कलर इज शोइंग compressive forces. This yellow color is showing the positive forces. Red color showing the compressive forces means your negative force it is. Yellow color means it is tension force, means it is the positive force. Obviously the member is what? If it is this kind of force, so it is what? Compression. It is trying to compress the element. And tension means what? It is carrying the force like this. It is stretching. So it is tension, it is the compression. Negative force, it is what? Your positive force. right? So this is the case. So this is what the positive and negative values. After that, I want to see in AB how much force is there. 6.928. Nature of the force or the sign of the force is what? Tensile. 6.928. Come back to your ETABS. Take your cursor here. How much it is? 5.192. Coming back to your manual calculation result, we have a trust on this manual calculation. So it is what? 6 point. Your result is showing what? 5 point. Okay. Come to BC, 3.46. BC, where it is? Yeah, 3.46. Come back to your ETABS. 3.48. Yeah, up to certain extent we can allow it. Okay, come to this AG. Where is AG? AG 8 kilonewton. It is compression nature. So nature is right or wrong? Nature is right. It is 6.4594. Your calculation is what? 8. Okay. Next, G2F. Yeah, GF is 5. Okay, 4.3. Or in actual it is what? 5. Will you accept this?
इसमें भी फर्क आ रहा है ना सर?
ये भी नहीं एक्सेप्ट करेंगे. देन फिर क्या कर सकते हैं? हाँ बताएं.
सर मुझे ये पूछना था कि आपने कुछ अजम्पशन बताए थे शुरू में इसके ट्रसेस के. तो उसमें हमने कुछ अजम्पशन किए थे कि उसके सपोर्ट में जॉइंट्स पे मोमेंट हम 0 कंसीडर करते हैं, यानी मोमेंट ट्रांसफर नहीं होती. तो वैसे हमने कोई मोमेंट रिलीज किए क्या सपोर्ट पे?
Yes, that is actually the point. Okay. Now let's try to understand the algorithm. Actually, whenever you are going to model in ETABS software, suppose one element I am going to take here and another element I am going to model here. This joint ETABS software is considering as rigid. Rigid means it is having the fixity. Means this joint is going to carry the movement. अच्छा ठीक है, यहाँ पर डिफरेंस इंटरेस्टिंग पार्ट है. अभी देखिए यहाँ पर रिजल्ट तो हम लोगों को डिफरेंस आ रहा है, बट रिजल्ट्स क्या है, ज्यादा मिल रहे हैं या कम मिल रहे हैं. तो हम लोग देखते हैं हम लोगों के मैनुअल रिजल्ट में. गो टू योर कैलकुलेशन A to B. Here your manual calculation is 6.9 and your software result is what? 5. कम मिल रहा है या ज्यादा मिल रहा है? कम मिल रहा है. Okay. A to G it is 8 and your software is showing 6.45 something. यहाँ भी कम मिल रहा है. Actually क्या है, your software what considering this joint where software is considering rigid. Rigid होने की वजह से ये कुछ मूवमेंट कैरी कर लेता है. तो जो आप लोड डाल रहे हो उसका कुछ पार्ट एज अ मूवमेंट कन्वर्ट होकर आपका ज्वाइंट इसको कैरी कर ले रहा है. सो एज अ एक्चुअल फोर्स इट इज नॉट ट्रांसफरिंग टू द एलिमेंट. दैट स्ट्रेस इज नॉट ट्रांसफरिंग टू द एलिमेंट. आपका ज्वाइंट उतना लोड बियर कर ले रहा है. ओके, दैट्स व्हाई ETABS सॉफ्टवेयर शोइंग द लेस रिजल्ट and your manual calculation showing the little bit more result. That is what the right. In manual approach we are considering this joint as a pinned connection. Pin connection means ये मूवमेंट कैरी नहीं करेगा. जो आपने लोड डाला उसका एक्शियल बनाएगा और उसको एक्शियल बनाकर ट्रांसफर कर देगा. आपने कैलकुलेशन किया होगा, यहाँ पर एंगल बनता है, साइन का एंगल बनाकर फिर वो लोड हम लोग ट्रांसफर करते थे. हैव यू रिमेंबर और नॉट? सो व्हाटएवर द टोटल लोड यू आर गोइंग टू अप्लाई, दैट टोटल लोड इज गोइंग टू बी ट्रांसफर टू दिस जितने भी एलिमेंट है उसको ट्रांसफर होते थे. बट द हियर इज व्हाट द सॉफ्टवेयर एल्गोरिथम इज व्हाट व्हेन यू आर गोइंग टू मॉडल this joint were considered by the software as rigid, और rigid होने की वजह से क्या करता है, मूवमेंट कैरी कर लेता है. बट हम लोगों ने assumption देखा था ट्रस का. we have seen that every intersecting point of the element is considered as a what, pinned connection, or we can say hinged connection, or directly we can say that the joint is not carrying any movement. Okay, but that assumption we have not applied to our model, our structure. So that is the problem only, nothing else. Everything is correct. That's why our result is not matching. So now we have to make these all joints as a pinned connection or hinge connection, or in simple you can say that we have to make this joint free from carrying the movement. We have to release the movement from both of the end. So उसके लिए क्या करना पड़ेगा, आपको एनालिसिस करने के बाद अगर आपको मॉडल में कुछ चेंजेस करना है, सो ऑब्वियसली आपके मॉडल को पहले अनलॉक करना होगा. जैसे ही आप एनालिसिस करते हो तो आपका मॉडल लॉक हो जाता है फॉर ऑल द बिगिनर्स. ओके, वंस यू कंप्लीट योर एनालिसिस योर मॉडल इज गोइंग टू बी लॉक्ड. आपको क्या करना पड़ेगा, फर्स्ट यू नीड टू अनलॉक योर मॉडल इफ यू वांट टू डू एनी एडिटिंग. ऑब्वियसली whatever, suppose मैंने 2 किलोन्यूटन यहाँ पर लोड अप्लाई किया था, उसके अकॉर्डिंग इसने एनालिसिस किया है. Whatever the load I have assigned to this joint, accordingly the load has been transferred. Now I want to change this 2 kilonewton to suppose 100 kilonewton. Obviously you need to unlock, because 100 newton all the loading will be changed to the element. Okay, that's why every time if you want to edit the model, you need to unlock your model first. It is asking that, please note, unlocking of the model will delete all your results. Yeah, okay, I'm ready. Just say okay. Now model has been unlocked. Now clear this all, close it. After this, some of you may think that the loading has been removed. Here the loading is not showing. So actually it is not the case. It is not in view only. The loading is there. So if you want to keep in view, or if you want to make sure that what load has been assigned to structure at what points, so you need to go to display, go to load assigns, and we have assigned the load to the joint or to the frame. Obviously we have assigned the load to the joints. So you need to go to joint, and under which load pattern we have assigned the load, under the live, check this and let's say apply, close it. Now it is in front of you. Otherwise go to display and just go to undeform. It will be what? Not in view. So it is not the meaning that it is deleted. Thereafter we have to assign the releases to all the elements. So select all the elements like this, cut all the elements from right to left. Cut all the elements right to left. This is the one way. Another way, individually you can click over this each element. That is also the one way. Our intention is just to select all the members, nothing else. This is the way. So it is what? 11 frames are there, that all are selected. Now go to assign and go to frame. These all elements are what? Frame. So assign. We have to do the assignment to the frame. Go to frame. In frame, we have to release the movement carrying capacity of the joint. Go to release. And on the left and right of every element. So left and right. There is a brief and interesting discussion about movement 2.2 and movement 3.3 that will come later after this truss. When we are going to analyze the beam, there I will explain in detail about the movement 2 to movement 3.3. But right now, just check this 4 box. Let's say simply apply. And this is the sign that mention that we have assigned the releases. Okay, this is all done. Now, undeformed shape, go to display, undeformed. Now, it is not in view only. It is not the meaning the releases is deleted or removed. Okay, it is not in view. After release, now perform the analysis. Let the analysis to complete. See, this is what the 3D and animated shape. Go to elevation along the grid first, say apply elevation view. It is what? Deform the shape. If I want to have normal view, so go to display and deform shape, not normal view. But the analysis has been done. Model is logged. Now I want to see the axial forces in the member. So go to display, go to force stress diagram, go to frame pair, live, axial force, and field diagram, frame, say apply, close it. Now see, come to this 6.9282. Go to this 6.928 tension. Then in this 3.4641, 3.460, very close. DC, okay, this will be same. AG is 8. Go to your ETABS. AG exactly 8. Next to that 5. Here G2F is 5 compression. Now you will accept or not. So this is the case how you can validate the results of ETABS software. So it is what? Axial forces in the member. So but here you need to remember, for the axial forces, positive color will be your yellow, means tension. A negative red color will be there, that is means what? Compression. That is the case. Again go to display, go to the force stress diagram, go to frame, and here user defined means scale. I would like to make it as 8. So it will large scale, apply slightly. Scale is going to, image is going to be, zooming will be there, simple language. Field diagram, along with that I would like to have the values. Check this, let's say apply. So the values will also, it is showing 6.9, 5, 8, 3, 1.7 something, Okay. Now, if you like to have only the values, not the colors, say apply, color will not be there. Are you getting? Hello.
Yes, sir.
So that is the case how to utilize this dialog box. Say, okay, this is done. Now close it. Now we'll move to the next example. Will you try this on your own? Yeah, this is what your homework. You have to do it. You have to practice it. I will discuss this one. Hello. You all are with me? Now tell me, how many grids will be there in X direction, or how many grids will be in Z direction?
5 grids in X direction.
US customary or metric SI?
Metric SI.
Metric SI, very good. You have to guide it. Guide for this model. Okay. Yes, tell me. How many grids in X direction?
5.
5.
1, 2, 3, 4, 5. Very good. It is 5. How many levels will be there? 1, 2, 3, 4. Very good. 4 levels are there. So additional level, how many? 1, 2, 3. ETABS software considering this as a base. So I am going to left it as base level. This is the first, second, and third. Additional 3, and this is the base. So total will become your 4. But we are considering it as 3. 1, 2, 3, and this is what? Base. So 3 levels will be there. Come to your ETABS. Number of grids in X direction, 5. Number of grids in Y direction. Hello.
1.
1. Very good. 1. Ratio of grids in X direction.
5 meter and 6 meter last.
5 meter is typical, right? Repeating value. And in Y direction, it will be 1. It is needed to go to custom or not?
Yes, sir.
Very good. Very good. Just go to custom, go to edit grid data, and display grid data is spacing. Your mind like this. Last one is going to become what? 6. Rest of all will be as it is. This is all done. Some dark color. So take okay. Now with all of this, just go to number of stories will be what? 3 additional. Typical story height is what? That we need to check out. We will see. Bottom story height. Okay, come back to this. How you will come to know how much this heights?
Tan inverse 8 by 15.
Very good. This triangle we are going to consider to find out first angle. Tan inverse of your height is 8 divided by your base 15. It will be your 15. Give me answer. 28.07 degree it is. Okay. Now this is what the angle. Now I just want to know this height. How I can calculate this? So it will become what? 5 times 10, 28.07, 2.66. Is there anything up to third digits? Tell me. 66. Okay, let it to be 2.666. Now this height I need to know. Now it is going to become 10 times 10, 28.07. Check it how much it is.
5.332.
5 point. So first is 2.666 and second how much?
5.332.
Now third is directly your 8. Now take the difference of these two. Take the difference of these two. 2.666 again you are getting. Difference of this 8 minus 5.332.
2.668.
Again 666. So these all heights are same. Equal heights they are having. Right? This height, and this height. Come back to your ETABS. So typical height will become what? 2.666. Bottom story. Again it is 2.666. If you are having the confusion, so no need to worry about. Go to custom, go to edit story. Now you can correct from here. Base is your 0. First is 2.6. Second is also 2.66. 3 is also 2.66. Cumulative height is going to become total height. Say 1 point. You can make it as okay 666 7. Try with this 7. Now it is okay. Hello.
Yes, sir.
Okay, so now it is exactly 8. Now you can say cumulative height is total 8. Let's say okay, and we need to have the grid. Check this grid. Say okay. With all of this, just short it. Go to elevation. and go to this first, let's say apply, go to elevation, let's say apply, this is done. Now come back to this, we have to start the modeling. So go to this frame, close it. This is the first point, this is the second point, this is the third point. I will have to take the help of the continuity. Click over this, click over this. Now from here, I need to come to this point, click over this. Unless until you are not getting the red sign or this grid point D1, it is what? It is showing that intersection. This is the label of this intersection. Okay, go to plan, come to any particular floor. So it is the B grid and 1 grid. If I am taking my cursor here, grid point intersection of B and 1, right? Grid point intersection of C and 1. So go to elevation first, intersection point, it is what? 1 and C. At story 2, how clearly it is mentioning everything. C and 1 at story first. So unless and until this definition you are getting, you don't need to click over that. Okay. So I am getting this. Now I am going to click over this. Okay. Or you can start from here. Click this first point. Coming to this. This is done. Now I am taking the. See why it is assigning the support here. Can anyone?
Because it's the base.
Yes, because it is at the base. That's why it is assigning. Yesterday I have explained this point. Very good. Yes. Click over this. Now modeling has been done. Right click over that. Okay. What next? Yeah, from here to here, we are having the point, click over that, right click. From here to here, right click over that. Then right click to off the continuity, coming back. Now from here to C, from G to D. From here to C, right click, from here to G, right click, this is done. And now here also the element is there, this is also done. Okay. After that, what? All the elements has been modeled. Your grids are very dark. So go to edit story and grid system, go to modify, color should be make it to light, say okay, okay, okay. Now, if you would like to off these grids, right click and set grid system visibility. Once you click over this, your grid will be off. If you would like to have your grid in front of you, right click, set grid system visibility, click over that, again it will be enabled. Again click off, on, like that. Okay, so your choice. If it is not needed to have this grid, you can make it to be off. After the completion of this work, here the support is what? Roller support. So drag it from left to right, select the joint. So how many joints in selection? 1. And then go to assign, go to join, go to restrain, and it will be your roller. And let's simply apply. The roller suppose has been assigned. Drag it from left to right, and it is what? Hinge support. Select this hinge and say apply. This is also done. Okay. After the completion of the modeling, what we need to do? We need to check our model, whether is there any modeling error or not. Go to analyze, check model, select all of these, and let's say simply okay. Let's check your model is right or wrong. Is there any problem in your model or not? No, there's no modeling error. Close it. After that, we have to assign the load. Tell me how much the loading is there? 24 Newton. Here it is 40 Newton. So Newton, how much it will be in kilonewton? Divide this 24 divided by 1000. Very simple it is 0.024.
Right, sir.
40 divided by 1000, that is going to become 0.04. Close it. Go back to your ETABS. Select this joint. Go to assign. Go to joint load. Go to force. It is under the live load pattern. It is minus 0.024. Say apply. This is done. Drag it from left to right. Joint is selected. It is what? 0.04. Let's say apply. This is also done. Okay. All the load has been assigned. It is what 0.024 is there, but it is showing up to the 2 digits only, 2 decimals only. Yeah, this is all done. We can proceed for the analysis. Now go to analyze and just click over this run analysis. It is first asking to save your model. So I will have to save this model by the name as 6. Let the analysis to complete. Okay. After this, go to start animation. This is what deform the shape of your structure. Okay, under the application of loading. If you are taking your cursor to any point, so what value you are getting for the 3D model, each joint will have how many degree of freedoms?
3 degree of freedom, sir.
3 degree of freedom. Who said? Actually, your model is having 6 degree of freedom. How many? 6 degree of freedom. Try to understand the concept. Forget about that all. Any joint, what possibilities are there? This joint can move in this direction. That is, I am going to call it as translational movement, horizontal movement, not movement. It is movement. Okay, displacement. So translational movement in X direction, translational movement in Y direction, UY. This joint can move up and down. So it is what? Up. Translational movement in Z direction. Rotational movement about X direction. Rotational movement about Y direction. Rotational movement about Z direction. Now tell me how many degree of freedom will be?
6.
Good. So this you have to remember. Each joint of 3D model will have the 6 degree of freedoms. So when you are taking your cursor to any joint, it will show the result. How much translational movement in X, Y, Z, how much rotational movements are. So that all things you can find from here. Just for your knowledge, for your information, I have shared this point. Okay. Now next. So I would like to make it as undeformed shape. Go to display, undeformed shape, normal view, lane. Then we have to see the forces. Go to display, go to force stress diagram. Reaction you can also see. Under the live load pattern, we have assigned the load and arrow format in Z direction only apply. It is 0.08, 0.02. Go back, see. Yeah, reaction is not showing. So, okay. Go to display, go to force stress diagram, go to frame pair, and under the axial force, automatic fill diagram frame say apply, close it. Check it, how much reactions? Okay, go to display, go to force diagram frame and make it as what? Show values also, apply, close it. 0.0274. Go back to your calculation, A to B, B to C, C to D, D to E. For all, the reaction is what? Tension, nature, 0.03, right?
Yes, sir.
0.03. It is 0.027, 0.0281, 0.0299, 0.0296. Is it right or wrong?
इसमें मोमेंट भी तो रिलीज करनी पड़ेगी ना सर?
मोमेंट रिलीज नहीं किया
हम
सर,
लोगों ने किया नहीं मोमेंट रिलीज, राइट?
मोमेंट रिलीज नहीं किया सर.
हाँ, अभी एक प्रॉब्लम और है. क्या प्रॉब्लम है वो? आपका ये एलिमेंट हम लोगों ने कंटिन्यूअस मॉडल कर दिए. देखिए आप, एक्चुअली क्या है, हम लोगों ने क्या अभी लर्न किया था, हर ज्वाइंट पे आपका एलिमेंट ब्रेक होता है, ट्रस का अजम्पशन है. सो ये भी हमारा मॉडलिंग रॉन्ग है, प्लस हम लोगों ने रिलीज भी नहीं असाइन किया है. बोथ द थिंग्स आर रॉन्ग. सो वी नीड टू चेंज द मॉडल. फॉर दैट आई नीड टू अनलॉक माई मॉडल फर्स्ट. से ओके, अभी पहले देखते हैं हम लोग इसको ब्रेक करना है. सो ये ज्वाइंट को लेता हूं, ये फ्रेम को ब्रेक करना है. सो सिलेक्ट द फ्रेम फर्स्ट, देन सिलेक्ट द ज्वाइंट, both of the joint and frame, then go to editor, edit frame, divide frame, break at intersection. Let's say apply with this, say apply. This is done. Now this is the separate, this is separate, this is separate. Now select the all elements. I am going to cut all the elements. Now go to assign, go to frame, go to releases and partial fixity, left right say apply. This is done. Now go to perform analysis. Let the analysis to complete. Start animation. Okay, this is right. Now go to display, post stress diagram, frame peer spindle. Let's say apply with all this. Now, 0.03, 0.03, 0.03, 0.03 exactly. Here all this 0.034, 0.034, 0.0 means 34. 34. It is what? 50. Okay. 34, 50, 24, 24. Here it is 0, it is 0, it is 0, it is 0. 100% correct or not?
Correct.
So in this way, you have to validate the result for the actual courses of the member. Okay. Hope that you might have learned a lot of important things with this trust element only. Now move to the next. We have to look at the beam. How to model this beam. So tell me, what are the different types of the beams? Prop the cantilever is a cantilever simply supported continuous fixed beam. Okay, based on support condition, there are so many different types of the beams. And the main concern for the design of the beam is your shear force diagram, bending moment diagram. Shear stresses and bending stresses that you have to find in your element, in your member. Actually, we have to model this beam and we have to see how much stress is coming to this member. But before of that, we need to understand some important things. So as I told you, your beam is a frame element. That means we are going to consider is a line element. So we have seen that each element will have its own axis system. Two axis systems are mainly, actually three is there, but most important is two. One is your global axis system, another one is what? Local axis system. Okay, global and local. So global axis system where software is showing by X, Y, and over height Z. But when you come to see at local axis means the member axis. So it is in X direction or not in X, along the longitudinal direction of the element. Longitudinal means along the longer side, longer span of the element. So beam is having along the longitudinal direction. So it is what software is considering as 1, 1.
Yes, sir.
Yes, sir.
Along with
Yes, sir.
software considering this as 2, 2. And along the height or depth, it is considering as along the height and depth, it is considering 2, 2. And along the third direction, it is considering as 3, 3. So local axis is representing by the numbering. Global axis is representing by the X, Y, Z. That is what the difference you need to consider it. After that, it might be in your knowledge, there are three equilibrium equations. What are those? Summation F of X, summation F of Y, summation F of Z.
Moment.
About the third axis, summation F of Z is also the third axis 0, or we are considering about third axis movement.
Yes,
Yes.
sir.
These are the three
Sir, yes, sir.
equilibrium
Yes, sir.
equation, third axis. So your beam is flexural element will be subjected to transverse loading only, and there is a presence of support to this bottom side. So transverse load means in this direction. Here the loading is, and your support is actually present here. Okay, so there is no question that your beam will be subjected to the loading along its longitudinal axis. There's no case the load will come along this direction, right or wrong.
Yes,
Right,
sir.
sir.
So your beam element is not carrying any axial force. First thing, okay. So for the beam case, we don't need to look at the axial force. Now, these two directions remaining 2, 2 and 3, 3. Very important point. No one will tell you about these all things in detail. I am trying to explain very important thing, try to understand. Now, along the depth. So if I am going to take a beam like this, which is resting over a support, and this beam is supposed subjected to any transverse loading. So under this application of the loading, your beam is subjected to what? Shear force. And shear force diagram, if suppose beam is subjected to uniformly distributed load. So shear force diagram will be what? Like this. Right or wrong?
Right.
Yes, sir.
If the only axial load is there at the center, shear force diagram will be like this. Okay, it means that over the support, your shear force is very, very large. Due to this very large intensity of the shear force, there will be the possibility of development of the shear cracks in this direction. So what I would like to discuss that your shear force is developing over the depth of your member. So your depth axis 2, 2 is there. Okay. So that's why whenever you are intention to look at how much shear force is coming to your beam, you need to look at the axis 2, 2. So this is called as major axis for shear. Major axis for shear is 2, 2. Minor axis for shear is what? 3, 3. And the third axis that is out of the plane we are going to consider. About that there is a possibility of the movement. That is the third axis for the movement. That is what? Axis 3, 3. So major axis for movement is what?
3, 3.
And major axis for shear is what?
2, 2.
Minor axis for shear is what? 3, 3. And minor axis for movement is what? 2, 2. Reverse it will be there. So, okay, you don't need to remember minor. You have to remember only major. So, if I'm telling you, let me know how much shear force in the beam, in which axis you will look at the shear force? 2, 2. If I'm asking how much movement in the beam, what you will look for? Axis 3, 3.
Yes, sir.
Yeah, but it is not the meaning that there will be no shear along the 3, 3. Some shear will be there that will be negligible. That's why we are going to call it as minor shear axis. And it is not the meaning that there will be no movement along the 2, 2. Movement will be there along 2, 2, but that will be very minor that we can neglect. So that's why we are going to call it minor axis for the movement 2, 2. Minor axis for the shear is 3, 3. Okay, so actually you have to remember very simple. Major axis for shear force is 2, 2, and major axis for your movement is what? 3, 3. Now go to this example. So you all said that it is a cantilever beam. You all are right. But one more thing I would like to know. It is elevation view, plan view, 3D view. What kind of view it is?
Elevation.
Very good. It is the elevation view. One beam is there or different beams are there? One beam is there. Okay.
One beam.
Come back to your ETABS. Okay. Tell me how many grids will be there in X direction? We are considering this model in XZ plane. So X direction, 4 grids, you all are right. I am going to take a, go to file, go to new model, say no this. Go to this third option. Metric SR is all. Let's say simply okay. With all of this, you said that we have to take 4 grids in X direction. You all are correct. 4 in Y direction. How many?
1.
1. Very good. 1. Spacing of grid in X direction. It is different, right?
Different.
Yeah. We need to go to custom. Make it as 1. Go to custom. Go to edit grid data. Go with this option. So now, first spacing is 0.5. 0.7, 0.8. 0.7.
No, sir, B is 0.7.
Yeah, 0.7.
0.8.
Very good. 0.8. Now, with all of this, make the bubble small. Okay, rest of all things as it is. Let's say okay. And it is not the matter of the level, but we are going to make it as all 1, 1, 1. Okay. And go to grids. Let's say okay. This is done. Now, close this 3D view. Go to elevation. Along the grid first, say apply, close it. It is the elevation. Base is also there. First level is also there. So your choice on which level you would like to walk. Tell me.
Story 1.
Base पर करेंगे तो automatically आपको बार-बार support assign कर देगा वो.
Right, sir.
Now come to your first level. Okay, coming back. This is the first point, second point, third point, fourth point. Actually, beam is 1. मैं क्या करता हूँ यहाँ से beam लेता हूँ, frame, close it. This is the first point. Trying to click over this point, right?
Yes, sir. Yes, sir.
But this option, what problem I need to face? यहाँ पर मुझको load assign करना है. It is what the point load. और point लोग आप लोगों को पता है joint के ऊपर हम लोग अप्लाई करते हैं.
Yes, sir.
मैं ETABS पे आऊंगा तो यहाँ पर joint में select कर सकता हूँ. See, I am trying. Yeah, end पर है joint. यहाँ पर भी है. But here it is not possible. तो इसके लिए क्या करना पड़ेगा? हम लोग undo करते हैं step को. टेक द फ्रेम, मैं क्या करूंगा, बीम इस तरीके से लूंगा. आई विल टेक द बीम लाइक दिस. सॉफ्टवेयर विल ट्रीट इट एज अ वन बीम, नो नीड टू वरी अबाउट. तो अब ज्वाइन में सिलेक्ट कर सकता हूँ, राइट. नाउ गो टू दिस सिलेक्ट ज्वाइन. First, we will assign the support. Clear this. Left is fixed. Select this join. Go to assign. Go to join. Go to restrain. So make it as a fixed. Let's say apply. This is done. Fixed support has been assigned. Now, after that, here the loading is 300, 500, 800. So 300 Newton. How much it will become?
0.3.
Drag it from left to right. Select the join. Go to assign. Go to joint load, go to forces, and under the live load pattern, how much intensity?
0.3.
अभी देखिए एक और चीज important, one more important thing. If I am going to click over this OK button,
minus 0.3.
minus 0.3. If I am going to press OK, so what will happen? The assignment will be done, but your dialog box will be off. Actually, I have to use that dialog box again, but it is what removed. Then I need to go to select the join, then go to assign for all the beginners. Okay. After a long time, you will come to know all these things. So go to assign, go to join load, go to force. Now it is available here. Now how much loading is there? 0.5. Join is selected. If I am going to select, click over this apply, assignment will be there. Plus your window will not off. This thing you have to remember, very basic. Drag it from left to right, joint is there. Assign the load as 0.8. Let's say simply apply over this. Now close it. After that, everything is now has been done. Now I need to go to analyze, check your model once. Let's say apply or click over this. Check your model. Is there any modeling error or not? This is done. Now perform the analysis. Okay, now analysis has been done, and animated start animation. Okay, right animation is there. Stop. Thereafter, go to display. First, I would like to see the shear force. So go to display. Go to force stress diagram, go to frame pier spindle, and here axial force. So will it be possible in your member axial force? No. Then I would like to see shear 2 to shear 3. In which axis you have to look for the shear? Very good. Shear 2, say apply. Now it is the shear value you are having. Make sure that the values are correct. Negative value, okay, 1.6. You see, shear force 1.6, 1600 Newton. Right or wrong?
Right.
It is what? Minus 300. 1600 minus 300. How much it will become?
1300.
1300.
Come to this. Right or wrong?
Right.
Right.
Right,
This
sir.
side
800. Correct.
800.
800.
This what? 1300 minus 500 is 800. Right. Next, I want to see movement. Which axis I need to look at?
3.
3. Check this
3.
movement. Apply. It is what movement? Negative movement is there. Okay. On the left hand side, minus 2.3 means 2350 Newton meter. 2350 Newton meter. 1.55.
1.55.
1550. Here it is what? 640. Right?
Right.
If you would like to see the values also, check this. Let's say apply. So value will also showing color if you want to off this. Okay, one more thing I would like to show you here. Very interesting. Red color means your negative movement. Red color means your hogging movement. When you will look at the plan, so plan, if suppose simply supported beam is there or fixed support beam is there, so the bending moment diagram will be like this. So here red color you will get, here you will get yellow color, here you will get yellow color, here you will get the red color. So red color means what? Hogging movement, negative movement. Yellow color means what?
Sagging.
Sagging movement.
Positive. Axial forces में क्या था? Red color means compression and yellow color means टेंशन। ओके, माइनर एक्सिस का देख सकते हैं ना हम लोग, शियर एज माइनर। माइनर में मैंने आपको पहले ही कहा वैल्यू आता ही नहीं है, बहुत माइनर रहता है। ठीक है, एक्शियल फोर्स अप्लाई, एक्शियल फोर्स इज ऑल्सो जीरो, एवरीथिंग इज जीरो। अंडरस्टूड? हेलो,
Yes, sir.
Yes.
now go to this, clear this all, close this and close it. What next? After this, okay, problem is what? Go to display, go to force diagram, go to frame pair and movement about 3. Some problem is there that I would like to share, apply. Okay, if you want to know more detail about these stresses, shear force, bending moment, so right click over this element. Once you right click over this element, so new dialog box will open, will give you all the information about this analysis result for this particular element. So ये member का देखिए, आपका लेफ्ट में उतना ही shear force है, राइट में भी सिर्फ इतने पार्ट का डिस्कशन है. For only this part there is a discussion. On the left hand side for this member, movement is what? 2350. 2.350 kilonewton. If you are going to convert in Newton meter, so 2350. Okay. Right hand side 1.55 means 1550. Close it. Right click over this intermediate one. Left 1300, right 1300. Shear force is uniform. On left 1.55, right 640. Okay. This is the deflection. At the mid part, there is a more deflection. At the end, there is a less deflection. That is what? How much the span of this beam? 0.7 meter. Okay. This is the scroll value. At what point you want to see the stresses? For 0.7, 0 to 0.7. I would have to see directly what is the exact value at 0.22179. Say enter. It is the point. Exact value you can find for that. Will you able to do it manually in manual calculation?
No.
Manually, it's very difficult. If I am giving the beam, simply supported beam, if I am giving and asking to find out the stresses for this beam, तो आप क्या करेंगे? यहाँ पर मूवमेंट निकाल सकते हो, यहाँ पर मूवमेंट निकाल सकते हो, सेंटर पर मूवमेंट निकाल सकते हो. If I am asking, I need to have the deflection at this at every 0.01 mm interval distance. Will it be easy for you?
No.
How much shear is there? How much movement is there? How much deflection is there? Will it be possible?
No, sir.
But that is possible here in the software. Okay, now close it. But that is not the important thing. Important thing is what? Actually, this beam is a single element and we have modeled this all in 3 parts. So that, okay, right, it is, no problem. But I feel it is not more correct. There is an option. We can model as a single element. But अगर single element करेंगे तो problem क्या आने वाला है?
Point पर loading नहीं दे पाएंगे.
Loading का assignment करना difficult होगा. Okay. So that is not the case. कर सकते हैं हम लोग. Go to unlock. Close it. Okay. And अच्छा, अगर मैं आपको कहूँ कि लोडिंग हम लोग अप्लाई कर सकते हैं तो फिर हम लोग वो 4 ग्रिड्स लेने की भी जरूरत नहीं है. स्टार्ट एंड एंड लेंगे. ठीक है. Go to file, go to new model, say no. Go to this third option, say okay. 2 grids only in x direction. In y1, it will be x direction, make it as 1. Go to custom, go to modify, go to display grid. Total spacing कितना है? I think 2 meter it is, right? So put it as 2. 2 and this is all done. Make it as 1000. Okay. Make it as 1, 1, 1 and grids. Okay. This is done. Close this 3D view. Go to elevation along the grid first. Say apply. Now go to frame. Close it from this first point. Directly going to this point. Right? Right click to off the continuity. Go to this option to completely off the command. Drag it from left to right to select the join. Go to assign, go to join, go to restrain, select the fixed support. Let's say apply. This is done. Now, in the last case, what we are doing, we are limiting to ourselves to assign the load to the joints only. लेकिन मैं क्या कर सकता हूँ? Point load frame के ऊपर भी लगा सकता हूँ. सॉफ्टवेयर ने हम लोगों को ऑप्शन दिया है, यू कैन असाइन द पॉइंट लोड टू द फ्रेम एलिमेंट. सो सेलेक्ट द फ्रेम, गो टू असाइन in this frame load. Now previously we are assigning to the joint. Now look at the frame load. Frame is giving the option to assign to particular point. Just go to this point and now go to this live. Now try to understand these things. You want to assign the force, okay. It is gravitational direction. Gravitational direction will always be bottom to top or top to bottom. What it will be? Sorry, top to bottom gravitational. ऊपर से नीचे आएगा आपका ग्रेविटी. सो इसका मीनिंग क्या है? यू डोंट नीड टू पुट अ माइनस साइन. रिप्लेस existing, you know very well what does mean by these three options. Now here two options are there: relative distance, absolute distance. Okay, relative distance means what? Whatever the span is there, it is dividing into four parts: 0 to 0.25, then 25 to 0.75, then 1. It is very complicated to understand. So don't consider it. Come to this absolute distance. At what distance, what load you want to assign, that's it. Which one is the easiest?
Absolute distance.
Absolute distance. So here, this is the complete frame. So for the complete frame, at what distance? It is a one element. So left end is 0, right end is total length. Remember, right point is the total length, 2 meter. So at what distance you want to assign the load? 0.5 from left. Okay, so at a distance of 0.5, how much intensity of the loading is there?
300 kilonewton.
See, unit kilonewton, 0.3. Okay, so just go to apply. Right, again, now make it is 0, make it is 0. Under the live load pattern, we have assigned this load. Remember, okay. Now, 500 kilonewton at a distance of what?
1.2 meter.
Select the frame at 1.2 meter. I want to assign 0.5 kilonewton. Is it needed to put minus sign?
No.
No, gravity is there. So I am going to click on this apply. Now 0.5 kilonewton load has been assigned, but this is now removed. Why it is?
Replace an
Distance.
Exactly. Replace an existing option is checked actually. So what option should be checked here?
Add to existing load.
Very good. Undo this step if you want to come back. So go to editor and say undo. So now you will come to last step. Now these option add to existing and let's say simply apply. Sorry, what's the problem? Element is not selected. Select the element, now say apply. Now, at what distance? 2 meter. How much intensity of the loading?
0.8.
At the distance of 2 meter, intensity is 0.8. Add to existing option is there. Let's say apply. This is done. Okay?
Yes, sir.
Now, this is the case. Now, perform the analysis. And okay, save this model. It is asking to save the model. Okay, once you complete the analysis, it will show the result. Go to display, go to force stress diagram, go to frame pair spindle. Under the live load pattern, all the load we have assigned. And first I would like to see the shear, say apply. Now it is showing what? Complete element. If I am going to right click over that, now the complete element in once it is showing. Okay, so on the left hand side is showing what? 1.6 kilonewton and 2350. So now it is very difficult to find the exact point. 0.5 sometime exact. So I can directly put what? 0.5. So at 0.5 this, then at what 1.2 what value is there that I can see, and I directly at 2 meter what value is there at the end that I can see. This is all about how to model the beams, how to assign the load, and then how to perform the analysis, then how to validate the results of the beam, shear force and bending moment, and what axis consideration is there, major axis, minor axis for moment and for shear. Hope that you all understood everything. Now the next example, again your cantilever beam, and as you can see here, this beam is not subjected to only the point load. It is not subjected to concentric load only. It is also subjected to your uniformly distributed load. So both of the loads are actually available here. Point load as well as uniformly distributed load. Both of the types of the loads are actually present here. So there is only need to provide the two grids. There is the first grid. This first grid actually and second grid is actually needed to have. So span of this beam is 2 meters. So we are going to do that. Come back to your ETABS and go with the use built-in setting meter with the metric SI unit system. Rest of all the things I am going to keep as it is. Let's say simply okay. Once you've done this, I need to go to put the number of grids in X direction as 2, number of grids in Y direction as 1, and spacing, actually that spacing will be what? One spacing will be there. That is totally from start to end is actually your 2 meter. And this point load you have to apply over the frame, over the beam. So tell me, it is needed to break the beam here, or I can take the continuous beam?
No need to break the beam.
Exactly, very good. So it is not needed to break it. We can take a single element, and it is actually single element. It is a single beam. Okay, so why you are going to break it? Need to go back to your ETABS, and with all of this, go to custom, go to edit grid data. So final, go to this. Final, it is actually 2 meter. Okay, let it to be as it is. These all things I would like to keep as it is. Levels I would like to take one, everything. Go to grid and say okay. Once you click over the okay, now go to elevation along the grid first. Let's say apply. This is the 3D view. I don't need to have this 3D view. Close it. Along the first grid, say apply, close it. Now I'm going to walk over this first level. So frame you have to take as usual, close it. This is the first point. Freely move to this point. Now your beam modeling has been done. Very simple. Then right click on your mouse. Now it is all done. Command is active, but the continuity is off. You need to click over this. Now the command is deactivated. Okay. Now I want to assign the fixed support on the left hand side. Drag it from left to right. Select the joint. Okay. This is the one way. Another way, you can directly click over this. So the joint will be selected. Your choice. Which option would you like to prefer? Okay. Select this. Go to assign. Go to joint, go to restrain, and here I would like to assign the fixed support. Select all of this fixed support. Let's say apply. Now close it. This is all done. Next, we have to assign the loading. So what loading is there? So first we have to assign the point load that is at a distance of 1.5 meter from the left end. So it is not the joint loading. It is what the frame point loading. So select the frame, go to assign frame loads. In frame load, it is the point load. Over a frame, you have to assign the load at a particular point. That is the one thing. Another thing is what? If suppose there is a joint and you want to assign the load to that joint, so you have to go to this joint load. But if you want to assign the load to the frame at particular point, so that will be your frame point loading. Okay. Go to this point and under the live load pattern, I would like to assign the load. Force will be there. Then absolute distance we have to take. I am going to take absolute distance. This is all done. Getting back to your question, and it is 2 kilonewton at a distance of 1.5. So very simple. At a distance of 2 meter and the loading is 1.5. Sorry, I did the mistake. Distance is 1.5 meter and loading is actually 2 kilonewton. Okay. Now it is the correct. Let's say apply. Sorry, frame is not selected. Let's say apply. Now it is done. Clear? So this is the way how to assign the point load over a frame, not over a joint. One thing. Second thing, I have to assign the uniformly distributed load over the frame. Now, it is the frame load. Okay? It is the joint load, frame load or area load. Tell me what type of this load? Either frame load, joint load or area load? Frame load. So where I will find this? Definitely go to assign. In joint, in frame or in shell. Where in frame it will be point or distributed. Just go to distributed and again it will be live load. Here the force and two options are there. Trapezoidal loading means what? Non-uniform loading. If suppose any case is there, that will come. Suppose non-uniform type of the loading is there. So for that loading, you have to go with these options. We will come to that point later. But for a full span of the beam, if suppose you want to apply the loading uniformly distributed of uniform intensity, so you don't need to go with these. Your work will be completed with this option only. क्या है, अगर आपका फ्रेम है, एक बीम है जिसके फुल स्पैन पर आपको यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड अप्लाई करना है, प्लस फॉर फुल ऑफ स्पैन, सो दैट यू कैन डू विद दिस ऑप्शन. लेकिन अगर आपका बीम है और वहां पर नॉन यूनिफॉर्म लोडिंग है और बीम है यूनिफॉर्म लोडिंग है फॉर पार्ट स्पैन, इतना है तो भी आप इससे काम नहीं कर सकते हो. यू नीड टू गो विथ दिस ऑप्शन. So here the condition is what? Try to understand. Just let me know. It is needed to go with this first option. Look at your example. Or second option is enough.
Second option.
Second option is here.
Okay, very good. So here the intensity is what? 1.5 kilonewton per meter running span. Okay, remember. So it is what? 1.5. Okay. One question I would like to ask. It should be replaced or add to existing?
It should be add to existing.
Okay, if I am proceeding with replace existing load, what will happen?
The another load will be deleted.
Another load will be related. Yes? No, it's wrong.
Yes.
Totally wrong. Actually, it is the point load and we are going to assign the uniformly distributed load. No relation between these two options. That's why I'm asking. So see, it is what? Uniformly distributed load. Okay, so it doesn't matter if what you are going to take here. So I am going to put here as 1.5 for full of span. Let's say apply. Your point load will also be there. This also, because see, try to understand. It is uniformly distributed load. It is the point load. Total option is changed. Yeah, suppose again I am selecting this frame. Now I am going to change. Suppose suppose my intention is to add 1.5 more to this. Okay. But I'm not checking this add, replace option is there. Suppose I have to add 2 more, 2 intensity kilonewton per meter more. So select this, say apply. So 1.5 will be removed and this new load will be assigned. Okay, so this is the case. See, but now if suppose I have to make it as 3, I am taking 1 here more. So option should be checked here what? Add to existing, then say apply. Now it is changed to 3. Select this frame again. Actual loading is what? 1.5. Replace to existing, say apply. This is done. Now we have assigned the point load also. We have assigned the uniformly distributed load also. This is all done. Nothing else we need to do. If you want to off this grid, right click on your mouse, set grid system visibility. Your grid will be off. This is all done. Now perform the analysis. But before of that, check your model. Go to analyze, go to check model, select all of these in addition to this option and just say okay. Oh, model has been checked. No warning messages were generated. That's a good thing. Now, after that, I need to perform the analysis. So go to analyze, just go to run analysis. So once you click over this run analysis, it is asking to save your model. So I'm going to save this as a title of 7 number of model. Save this file. Now it is proceeding for the analysis and will give the deformed shape of your structure under the application of the loading. Now, I would like to see the shear force. So, can anyone guide me how I can see the shear force and bending moment?
Go to display.
Okay.
Then forces and stress diagram.
Okay. Then.
Frame spear
Okay. Then I want to see for shear.
Shear to 2.
Shear to do.
My
Anything else?
Select case load, live load.
Very good. Here we have assigned the load under the live load pattern. So I would like to see the results in live load pattern. Okay. Then rest of all things will be as it is. Show value at the controlling point. Okay, very good. Let's say apply over this. So now this is the results you are getting. But I want to see more detailed result. What I need to do? Can anyone guide me? Right click over the member. Once you right click over this element, right click over that. So you will have this informative box that will tell you how much reaction forces are there, how much shear forces are there, how much bending moments are there, and how much deformation and deflections is there. Okay. Our main concern with your shear and movement. So major axis for shear is 2, 2. Major axis for movement is 3, 3. On the left hand side, shear for is what? 5 kilonewton. Come back to your calculation. It is 5. Okay. here at a distance of 1.5 meter, total intensity is what? 2.75. See, it is very difficult for me to find the right point. So what I will put here as 1.5, say enter. Now it is 2.75. Go back to your this 2.75, right or wrong?
Right, sir. Right, sir.
Okay, coming back. So on the end, it is the free end, zero movement, zero shear force, good movement, and the left hand side 6 kilonewton. Coming back 6 kilonewton at this point, 0.1875, 1.5 meter, 0.1875. That is also right. You can check your deflection also. Here calculation for deflection is not present. Otherwise, you can also verify the deflection. So this is the way how to model the beams, then how to assign the load. So up to now we have learned how to assign the point load over the joint, how to assign the point load over the frame. Now we have seen that how to assign the uniformly distributed load, or you can say the line load over the frame element. Now next example we are going to look at. This is the example which is subjected to uniformly distributed load plus uniformly varying load. This is called as what? Uniformly varying load, because the variation in the intensity of the loading is there. So this example we have to try and we have to check whether the results are matching or not. First thing, tell me how many grid is needed to take, how many grids you have to take. It is not going to influence by loading. If I am going to remove the support, I am considering only the beams. So I can take only 2 grid. You can assign the loading by any way, or for any type of the loading you can assign the load. एक्चुअली सपोर्ट जो असाइन करना होता है यह आपका ज्वाइंट के ऊपर ही सपोर्ट असाइन होता है. सपोर्ट आपको फ्रेम के ऊपर असाइन करने का ऑप्शन नहीं है ETABS में. कम बैक टू योर ETABS. देखिए असाइन, सो ज्वाइंट के ऊपर ही ऑप्शन है आपको. देयर इज नो ऑप्शन टू असाइन द सपोर्ट टू द फ्रेम, टू द शेल एंड अदर्स. ठीक है, मैं एक फ्रेम ले लेता हूं और सपोज यहां पर हम लोगों का कहीं पर सपोर्ट आ रहा है. आई जस्ट वांट टू, डोंट कंसीडर द लोडिंग, फॉरगेट अबाउट द लोडिंग. मुझको सपोर्ट असाइन करना है इस पॉइंट पर. विल इट पॉसिबल फॉर मी टू असाइन द सपोर्ट टू दिस पॉइंट? इफ कंटिन्यूअस फ्रेम इज देयर, नहीं ले सकता हूं मैं. फ्रेम के ऊपर आप सपोर्ट असाइन नहीं कर सकते हो. उसके लिए चाहिए आपको ज्वाइंट. आप कहेंगे मैं यहाँ पर ज्वाइंट लेकर सपोर्ट असाइन करूंगा, दैट विल नॉट वर्क. ओके, इस तरीके से नहीं करना है आपको. बीम को वहां पर ब्रेक करना पड़ेगा आपको एनी हाउ. सो दिस इज द केस. सो यहाँ पर एक फ्रेम इसको कंसिडर करेंगे. दिस इज द अनदर फ्रेम. सो 2 frames आर देयर, 1 and 2, एंड द ग्रिड्स विल बी व्हाट?
3.
1 2 3. सो हम लोगों को यहाँ पर ज्वाइंट मिल जाएगा. गो टू फाइल, गो टू न्यू मॉडल एंड से नो, and go to use inbuilt setting, metric SI. Rest of all things will be as it is. Let's say simply okay with all of this. Number of grids in X direction will be 3. Number of grids in Y direction will be your 1. And spacing of grid, let it to be as it is. We need to go to custom, go to edit grid data. We need to go to display grid data as spacing. This is all done. Come back to your A to B is 10 meter. A to B in difference of A is actually 10 meter. B to D in difference of B, it is 16 plus 4, 20
meter.
20 meter. Rest of all the things I am going to keep as it is. Okay, storage take as 1 1 1. Now go to grids, say okay, this is all done. Now close it, go to elevation along the grid first, say apply. This is done. Okay, now frame, close it. This is the first point. We really move to this point. This is done. Click over that. Take the advantage of this continuity. Come back to this and now press here. Right click. Now right click on your mouse. This is done. Okay. Now a command is active. If you want to off this command, close this command, press escape as well as otherwise click over this. Both of the options are there. Next, I have to assign the support first. So I need to have the joint here. Drag it from left to right so the joint is now selected. Go to assign, go to join, go to restrain. It is what? It is the roller support. So it is actually what? Roller support. Apply this. This is done. Roller. Drag it from left to right. On this side, how much it is? Hinge support.
Hinged support.
Go to assign, go to join, go to restrain. and it is what hinge support, say apply. This is all done. Okay. After that, we have to assign the loading. So what loading is there? Here on the left hand side cantilever portion, we have to assign the uniformly varying load. So how to assign the uniformly varying load? Very interesting it is. So tell me, this uniformly varying load is over the joint, over the frame, or over the area? What it is? Over the frame it is.
Sorry.
Select this, go to assign, go to frame load. In frame load, there is no option as non-uniform loading. Okay, we need to go with the distributed. In distributed, under the lie load pattern, rest of all things as it is the uniform load. As I told you, if your single element is there for full of span of uniform intensity, this case, so it will work. But here it is what uniformly varying. So I need to come here, select the frame. I need to go with this option, uniform varying, trapezoidal loading, go to absolute distance. No need to work with relative. Go to absolute. Now, at 0 for this frame, at start point, loading is what? Check it. How much intensity at this start point?
0.
0. So it will be 0. At end point is what? End point is what? 10 meter. And intensity is what? 2. Okay. So let's just simply apply. Now, for this span, can I work with, for this span, 20 meter, intensity is what? Again 2 kilonewton per running meter, but it is what? Uniformly distributed load. Can I go with this option? Uniform load?
यूनिफॉर्म लोड से अगर जाते हैं तो पूरे 20 मीटर पे यूनिफॉर्मली लोड दे देगा वो 2 किलो न्यूटन का, हमें 16 मीटर तक ही देना है.
वेरी गुड. हम लोगों का एक्चुअल में यहाँ पर पार्ट लोडिंग है. ओके, 16 मीटर तक के, बीम आपका 20 मीटर है और लोडिंग अप टू स्टार्टिंग ऑफ 0 टू ओनली 16 मीटर, यहीं तक के लोडिंग है. अगर फुल स्पैन होता, मैंने पहले ही आप लोगों को बताया, फुल स्पैन होता तो आप लोडिंग अप्लाई कर सकते थे विद दिस ऑप्शन. लेकिन आपका पार्ट लोडिंग है, सो यू कांट प्रोसीड विद दिस सेकंड ऑप्शन. ओके, इसमें सेकंड ऑप्शन इज एप्लीकेबल ओनली व्हेन यू हैव टू असाइन द यूनिफॉर्मली डिस्ट्रीब्यूटेड लोड और फॉर फुल ऑफ स्पैन. लेकिन दोनों में से एक भी कंडीशन अगर लैक करती है और चेंज होती है तो आपको ट्रेपेजॉइडल लोडिंग ऑप्शन से ही जाना पड़ेगा. क्लियर? सो हियर वी हैव टू असाइन द पार्ट लोडिंग. सो वी नीड टू गो विद दिस एब्सोल्यूट at for this frame. Now it is the another element, so it is going to become 0 distance, and now it is going to become 16 meter. Okay, so this is what 16. So at 0, how much intensity will be?
2 किलो न्यूटन.
Very good, 2 kilonewton. And at 16,
सेम 2 किलो न्यूटन.
2 kilonewton. Say apply. This is the case. This is all done. Now, after this all assignment and loading and modeling, we need to check our model. Go to analyze, go to check model, select all of this along with this, say okay. Model has been checked, no warning messages are there. Go to analyze and go to run analysis option. Now again, I'm going to save this file. Let the analysis to complete. Once the analysis gets completed, see, this is what deformed the shape of your structure. Under the application loading, click over this, go to display, go to force stress diagram, go to frame peer. I would like to see the result under live load pattern movement, say apply, done. Now, here intensity is what? See, movement. This another element, this another element. So right click over this element. So left portion, that is what? Cantilever. So on the left hand side, 0 movement, 0 shear. On the right hand side, maximum movement, maximum shear. 10 and 33.33. Go back to your calculation. Left is 0, right is what? Movement is 33.33 and shear is what? Shear value on this side, it is not showing the negative value that I can need to understand. It is 10. It is not showing actually here, but movement is what? Right or wrong?
Right.
Movement is correct. Okay. Now close it. Right click over this. Now on the left hand side, shear force is what? 20.8667. 20.8667 positive value. Okay.
Right.
Now movement at this 0 point, or yeah, directly I can see the movement at the point of 16 meter. Go back. Movement at the point of scroll value at 16 meter. Say enter. shear force is 11.13 and moment is what? 44.53. 44.52 and there is 44.53. So almost it is a matching. So that is the case. So will you practice this example on your own? This is considered as hinge support. This you have to consider as roller support. Will you practice this or not? So this is your homework. You have to do it. You have to practice it. Thereafter, just come down. This example, again, you have to take on your own. Okay. This is the example where you have to consider only this loading 80 kilonewton, this loading 40 kilonewton, and this is your fixed support. This is your roller support, this is your roller support, this is your fixed support. And this 50 kilonewton per running meter intensity of the loading for the span of 4 meter B to C. This movement is not actually the loading. These are the results. You might have studied about moment distribution method in your academics. So this problem has been solved by that moment distribution method. So in moment distribution method, what we are doing? We are using the carryover factor for transferring of the moment, and we are going to rounding of the moment, and finally we are getting the result, round of results. That is what approximate result, not the exact result we can call to that answer, that result. So this problem was solved by that moment distribution method, MDM. So it is the second step of example. ये क्या है? थोड़ा सा एक नेक्स्ट स्टेप है. एक्चुअली आपका लोडिंग क्या है? यहाँ पर एक फिक्स सपोर्ट है, यहाँ पर आपका फिक्स सपोर्ट है. देन हियर देयर इज अ प्रेजेंस ऑफ रोलर सपोर्ट, हियर देयर इज अ प्रेजेंस ऑफ रोलर सपोर्ट, एंड दिस इज 1 मीटर, this is 1 meter, this is your 2 meter, it is your 2 meter. Now from here to here it is the 4 meter, and now it is 2 and 2, 2 and 2, total 4 meter. So here at 1 meter the loading you have to consider how much it is, 80 kilonewton. Here the loading is what, 40 kilonewton, and here the intensity of the uniformly distributed load is what, 50 kilonewton per running meter. That's it, nothing else. With all of that, you have to try this example on your own again, and the result will not exactly match. Why it is? Because this calculation has been done by the moment distribution method, and there it is what, rounding of factors are there. Rounding of factors are there. That's why your ETABS result and your this example result will slightly different. So that you have to accept. That's it. So this example and this example you should try on your own. And all the things I have covered, nothing is remaining. Everything I have completed. Okay. You can try these examples on your own. And if you are facing any problem, then let me know. So this is what the end of validation of your ETABS software.